Let me pull this up. And so good morning, good afternoon, everyone. I'm Baris Deniz. I'm heading up Age Solutions, who are focusing on integrating AI into our research, HR research workflows. Uh, I will talk about a process that I have been using to translate existing health economic models into executable code. Uh, so the purpose of this talk will be still around that specific topic, but also yesterday we attended a panel. There were a bunch of different questions around how AI can be used in research, more generally speaking. So I will try to address that as we go through this as well. So try to address two different topics. So modeling has been always a translation activity. What we do here is really trying to conceptualize a disease state or a treatment pathway or overall disease management paradigm into a mathematical formula. And as we do this, over the years, accumulation of our experience, how we think things should be done, good research practices, the guidelines, and requirements from HTA agencies, we accumulated a lot of tacit knowledge. What this really means is when a modeler, experienced modeler pulls up a model and then reads an article, for instance, he or she immediately understand how the model design was conducted, how some of these implicit assumptions are executed, and it is very easy for experienced model to follow the description very easily. And that's why when we look at some of these publications that are in the public domain, there are a lot of gaps that we leave, and there are multiple reasons for that. The space restrictions is one, but also some of these things are very native for us. We immediately pick up on what the implicit assumption there. One good example of this is the discontinuation. When you look at different papers, discontinuation may mean several different things, but they're not necessarily explicitly discussed in the article. It can be a state transition, it can be a new arm assignment, it may be a model exit, and so forth. But these are the things that really makes it very difficult to bring in LLM directly into the model development and expect them to read a description of a model article and then replicate it or build a very close replica of that model. The issue, though, is not only that, but LLMs, when they fail or they do not understand that assumption or cannot link that assumption to a consequence, they will fill those gaps silently. So they will not raise their hand and say, there's this information that is missing, and this is how I'm going to handle it. They will just build in things into the model, and then they will still produce, most of the time, runnable codes without really showing how the whole structure is put together. Again, this is an article that I will show you as an example. Here, Heinz stopping rules comes from the NICE context, as this model was prepared for NICE submission. Without that context and nuance, LLM or machine will not really understand how that assumption should be built in. So the process I'm offering here is, instead of dumping a large description of a model that will have implicit and explicit assumptions, creating this multi-step approach that can decompose the process and help the researcher actually walk through those with full awareness of what the design of the model is and what is assumptions and different data points that are embedded in there. This is also touching on that second objective that I mentioned, which is LLMs, when they are put into right systems and right design, they can be really strong research companions. Instead of a researcher trying to figure out all these details by themselves, LLM can surface those critical information, assumptions, structural or parametric, into the researcher's awareness, and then researcher can work with LLM to untangle and understand the whole structure together. So this is the process that I'm going to walk you through. Here you will see, and I will show a demo video of this as well. There's a published article which then gets dissected into certain structures and domains through LLMs. Here, LLM takes the second shot at it by reviewing it critically and surfacing the assumptions that are in the system and which data points are available versus not. This is the point that it pauses and brings the expert into the mix, where expert can interact with the system, again, ask questions, pressure test some of these assumptions, understand the sources of those, and make any changes that they may want to make to make sure the model that they're building is actually fit for their own purpose, not necessarily replicating that model, but also understanding implications. This is also a handover. This is creating the paper trail. How we finalize this is an important point. Then that can be uploaded to coding agents, so to speak, following the specifications as the blueprint, create the code, and then take another pause for expert to review, again, look at the results, ask questions, and so forth, which again gives another chance for us to steer the system the right way that is appropriate for our research question. So starting with the first one, I'm going to go through this relatively quickly because I will show how this works in action. But the first one is really ingesting the information and putting it in a structure that is easy to review for the researcher, quickly get a sense of what the model does, how it works, what are the populations, and so forth. And we can have this as a printout from the system as we move forward. The second one is, again, the system is looking at this description and extracting all the possible assumptions, explicit or implicit, as well as the data gaps that we have in the publication or the summary. This is helpful for a user to, again, look at, ask questions, and finalize before they move forward. Once we say, okay, this is great, I agree with this, or make changes if that is not fully aligned with what we're trying to do, we can finalize this as the blueprint, which then gets into the coding portion of the module of the system, where the coding agent actually use deterministic scaffolding, which is basically ensuring the code generated by the system is consistent across different models. It doesn't necessarily try to solve very well-known and established areas like discounting, half-cycle corrections, and so forth, but then take what is different and nuanced about this particular model and build the code around those features. And at the end, it creates the traditional R code or Excel code as well, if user chooses to go down that route. By doing this, we are basically limiting the hallucination surface for the LLM. So it is reducing all these made up structural assumptions, made up data. Everything is in front of a user and the modeler. So let me show very quickly how this works in real practice. Let me show, Rob, please, if you cannot see this.
That's great. Yeah, we can see that. We can see that.
Okay. So this is the first step that I was talking about, which is ingesting the published article that I just uploaded. There are multiple steps here, intentionally, as you see, that system follows to create this detailed specification document that the user can, again, go through this very much like in a website, review what information the system pulled in from the publication. But not only that, it also provides a general summary of what this model is intended to do by looking at the description that we provided. This is, again, first good check for user to say, you know what, this is actually aligned with what I'm trying to do or not. But then also it gets into details around, okay, these are the assumptions that the model is making. Here, user can go in, override some of these assumptions, tweak them if they wanted to, at a minimum, understand how this model was designed to work, and so they have full understanding of how this is gonna be built. This is not only for viewing. The user can actually get into the collaboration portion of this, ask very pointed questions, better understand the, again, data sources, the structure, the assumptions, how this is going to work. And AI becomes, again, a research companion. So it is not only, here's your answer, but working with the model directly to figure out how this can be tweaked, revised, or if it is the intended model that we're going after, confirm that that is the case. If the user wants to make changes, they can jump into this specs, which will be obviously blueprint for our coding, and play around with this, again, to ensure what we are doing is fit for our purpose. And good thing is the system creates this paper trail. All the changes we are making, all the questions we're asking to AI can be documented at the end and downloaded for the final step. Here, what it generates as the specs. Again, this is a downloadable document, which is important for us to have this handover to the coding portion. And the coding uses the specs that we just generated, validated, or finalized. And the system basically ingests this information, again, follows multi-step process to understand what is the intent of this model, what are the structural features. It self-corrects itself, validates by running a bunch of different tests, and then brings up back, again, the user interactivity or the research companion piece, which is, these are the tests that we run around the confidence layer. These are the results of those tests. Again, the user can pick this up, start asking questions. It can ask questions about specific tests we ran, how it failed or what happened there, whether those quote unquote failures are true positives or false positives, how this aligns with the model structure that we had in mind. And if they wanted to, again, realize some of these things are actual deviations from the original intent, the user can say, you know what, let's update this and then bring back the coding agents or the coding module into the mix to make those changes and then implement them through the same process, QC it and validate it again after the change, which is what you're seeing on the left right now. Adding this as like a shopping bag, and then once we say finalize, the system takes this and goes back and reruns the whole process. The other thing I was gonna mention, maybe let me fast forward. I think the valuable point here, and this was a question yesterday as well, LLMs being a black box in the HTA context, what they generate, how are we gonna trust those? I think it is important to separate the engine that creates the evidence that goes into external audiences versus the evidence itself. When evidence is our code that is following our good research practices, the organization of the code, etc., it is really easy to review and debug it, which is, in my view, needs to be the final endpoint rather than the engine itself that created this code at the first place. But this can be reviewed, tested with the processes that we already have and have been using all along. But this becomes the deliverable rather than the underlying LLM that generated this code, along with the paper trail and everything else. So let me move on to next, just to sum up. So this is again, auditable, traceable, transparent process that creates eventually the R code that is fully in the control of the researcher. We know what goes in there, what the data sources are, their manipulation, how we implement the time dependencies and so forth. But all these critical steps get a researcher input and validation and approval before the system goes forward. Very much like, again, a research companion that turns things around for us very, very quickly. And at the end, what you have then is the code that runs which is again can be anything, any way these LLMs can generate something that you can trust because you know inside out what went in there and the decisions that led to that. This is tooling independent, whatever LLM or other tools that you may be using doesn't really matter. At the end, you're getting the R executable R code or Excel file, which is very similar to what we would submit to HTA agencies. And the key point here is really the transparency, traceability, and the control that we have over the system for us to get the model documented and created at the first place. So with that, let me pause. I think I'm a few minutes ahead or over, rather. But thank you.
Thank you very much, Baris. That was great, as always. We're a few minutes over, so I'm gonna open up for one or two questions before we move on. But please also feel free to put your questions in the chat, and I'm sure Baris will follow up on those as well. So we do have one question from the chat already from Howard. How does your approach compare to the skills Ian Cromwell yesterday showed us for Claude? From a user perspective, skills seemed less resource intensive to develop.
That's a good point. It is, I think, the difference is really I have with this type of a structure, we have more control over what LLM can or cannot do. Skills typically defines the or provides the guidance around how the system should handle different edge cases. But it still leaves a lot of room for LLM to improvise as well. With this type of structure in the back end, it is all structured and there are stopping points for researcher to get in the mix, ask questions, and discuss the approach with the system altogether. Skills do not really allow that much of an interaction with the user. It will just do the task that is defined within the skill, provide the output, and whatever we do with that output is again needs to be built on as a separate skill or a separate process later on. This basically encompasses the whole pipeline.
That's great. And then a second question from Ben. So wonderful presentation, thank you. Do you know of any good agentic pipelines for red teaming / adversarial review, like peer reviewer 2 of R models for HTA?
Yes, that was actually my other abstract for the conference that didn't get through. But yes, so I will be happy to talk about this in more detail, but this is obviously one aspect of creation of the model. There is the red teaming as the question stated, that can be done, which takes the specification, looks at the final code and do both technical review as well as validation, whether that is the right question that we're answering and so forth. There can be, I think that was also yesterday, I briefly talked about simulated advisory boards that we can build that bring in statistician and the clinical expert and the health economic expert, create a panel to review this information, the decision problem, etc., which will give more also specific assessment of the model. But yes, there are multiple different modules that are available to tag on to this to pressure test almost independent review of what we have generated before it goes to any external stakeholder.
Great. Well, thanks so much, Baris, again. It's fantastic as always, and look forward to hearing more. So please put any further questions in the chat for Baris. I'm sure we'll get back to you.